Hello, this is Mrs. Glenn, or the Math Tuber. I'm going to show you how to find the surface area of all of these figures. So let's get started. Okay, first is a rectangular prism. So what I like to do is actually label my sides and find each side and then add them all together. That's the easiest method. I do have another video showing you how to do the formulas, so you can choose either one to help you. But for my students, they understood how finding the surface area using the side method. So let's do the bottom. And this method you can use on any figure you're trying to find the surface area of. If you always call it the bottom, it just pertains to everything, because otherwise if you use the word base, the base of a triangular prism, for example, is a triangle. But the way that triangular prisms are shown in a textbook or online is normally on its side, and the bottom of the triangle is a rectangle, not a triangle. So I like to use the word bottom because that's the easiest one that fits pretty much every figure that you use. So we have bottom. The opposite of bottom is top. And then you have left. The opposite of left is right. And then you have front and back. Now we know that a rectangular prism has 6 sides, so we want to make sure that we have 6 titles. So there's 6 here. That's good. All right, so the bottom shape, if we were to make this shape actually see-through, would look a little bit like this, and then we would have a line that goes down in the back over here. So the bottom shape is a rectangle. And the top is up here, and that's also a rectangle. And I like to draw it in the order or the orientation that it's in, so that we can actually, see that it's a long, thinner rectangle, and it just makes better sense in my mind. And then the left-hand side is the one we can see. So that is a rectangle again. And the right is also a rectangle, hence the word rectangular prism. And then in the front, it's a thinner rectangle. And in the back is also a thinner rectangle. So let's put some dimensions to all of these rectangles. We have the bottom, which is 5 by 2. We have the top, which is the same. These lines are parallel, and they are within a 90-degree angle on both sides. So this top is also 5. And the 2 here also is corresponding to the 2 for the top of the top side. So that's also 2. The left-hand side, we're going to look here for our height, and the lines that are parallel with that, they give us 1, which is 5. And this way is our base, and that is also 5. And on the back side, that's the right, that's 5 by 5 as well. The front, which is over here, that's 2 by 5. Notice how I label the 2 down here, the base, down here, on my, when I'm putting the dimensions into each side. I'm putting them into the dimensions the way that it is oriented in the figure. That's just going to help you organize your sides better if you do them in the same order. And in the back, that's also 2 by 5. So 5 is the longer side and 2 is the shorter. So now I like to actually go through and just do the multiplication for each. So surface area of a rectangle is base times height. And I like to just write it BH. So I'm going to multiply the base times the height on each one of these. So 5 times 2 is 10, plus 5 times 2 is 10, plus 5 times 5, 25, plus 5 times 5, 25, plus 5 times 2, 10, 5 times 2, 10. Now before I add them up, I'm going to make sure I have all 6. So 1, 2, 3, 4, 5, 6. Then I'm going to add them up across. So I've got 10, 20, 70, 80, 90. And what unit is it? Millimeters. And we're doing surface area, so it's squared. 90 square millimeters. And that is how you do the first problem for a rectangular prism. Let's move on to a triangular prism. So again, we're going to write bottom. And does this one have a top? No, it's the crease or the edge of this figure. So that's not a top, so we're not going to include it on that one. Then we have the left, the right, the front, and the back. So the bottom is a rectangle. The bottom of this figure, if we were to continue to draw this to make it see-through, would be something like this. Okay, and then the left-hand side is the side we can't see. So that is the slant for 6 and 6. So that side back here is 6 and the base is 4. So we're going to draw the left-hand side. And then the right-hand side is the one we can see. So that's also a rectangle. The front of this triangular prism is a triangle, which is the base. That's why the name is triangular prism. And the back is also a triangle. And so the bottom is 3 by 4. And the left-hand side is back here, so that's 6, because this triangle, even though my blue is not perfect, it is actually an equilateral triangle. So these 6s back here are the same. Not an equilateral, I'm sorry. But these sides of the triangles are both the same. So 6 for this side and then 6 back here for that side. So if we wanted to make it a little easier, maybe we could write 6s on both of these so we know. And the left-hand side is 6 by 4. The right-hand side is the same. And the triangles, the height of the triangle is 5. The arrow is pointing to 5. And the base of this triangle is 3. And that's the same for the back side. Now we're just going to do the area of each of these, or use the formula to find the area of each of these. So for a rectangle, it's base times height. And for a triangle, it's base times height divided by 2. All right, so 4 times 3 is 12. 4 times 6 is 24. 4 times 6 is 24. 5 times 3 is 15. Then dividing it by 2 is 7.5. And I show this to my kids in the classroom. If you were to make a rectangle or a square and divide it by 2, diagonally, you have 2 triangles. So that is why you divide by 2, because you can fit 2 triangles, 2 right angle triangles, into a rectangular square. So that's why you divide by 2. So this is 5 times 3 divided by 2 again, so that's another 7.5. And then we're just going to add them up straight across. So you have 12 plus 24 plus 24 plus 7.5 plus 7.5 equals 75. And it's inches squared. And let's move on to the next problem. We're going to circle our answer. All right, next is a pyramid. All right, so we were to draw the sides again, we'd have bottom. And see how bottom fits for any figure you use. We have bottom, we have left, right, front, and back. Do we have a top? Nope, it's the point at the top, so that's not a top. So the bottom is a square. So this is a right square pyramid. And the left-hand side is a triangle. The right-hand side is a triangle. The front is also a triangle. And the back is a triangle. Okay, so the bottom is 3 by 3. Our height for the triangles is 5. And the base is 3. And because this is a square, we know all of our bases are 3, because these have the bases around the edges are the triangles. And then our height is the same all the way around, 2, because they did not give you any other dimension. So these are also 5. Alrighty. Dozen red roses. Okay, so now we're going to just do the math. So we have 3 times 3, which is 9, plus 5 times 3 divided by 2, 7.5, because that's 3 times 5 is 15, divided by 2, because 2 triangles fit in a rectangle, is 7.5, and this is the same, so 7.5, and then 7.5 again, and 7.5 again, and I know that 7.5 plus 7.5 is 15, so that's 30, plus 9 more is 39, and it's feet squared. That's your answer for that one. It's just the same repetitive pattern. If you can do a circle, rectangle, triangle, you can pretty much find any surface area. All right, moving on to a cylinder. So this one's a little bit tricky because there's no left and right or back and front. So we're just going to do bottom, top, and I like to call it the side. So it's the side that goes all the way around. All right, so the bottom is a circle. The top is also a circle. And the side, like a soup can label, if you take the soup can label off, it is a rectangle. So you can pretend like this is a tuna can because it's kind of short and fat. So if you were to cut this label off and open it up, it would be a soup can label. Now that makes an important point because we're not able to get the length all the way around this cylinder. So the distance around a circle is also known as circumference. And if you look on your reference sheet, circumference is found by going pi times d, or doing pi times d. That is circumference. So the circumference of that circle is also the length of our rectangle. So I'm just going to put pi d there. So we have the radius of the circle is 9. The radius of this circle is the same, 9. And the height of the cylinder is the same as the height of the rectangle, and that is 5. So for a circle, the area of a circle is pi r squared. So I'm going to do 3.14 times r squared, which is 81. And 3.14 times 81 is 254.34. And I'm going to add that to the same here, 254.34. And now for this one, I have to do pi d. So I have 3.14 times the diameter of the circle. So if I know the radius is halfway across, to go another halfway would be another 9, and 9 plus 9 is 18. So 3.14 times 18 is 56.52. So instead of writing pi d, now we can change this to 56.52 and find the area of this rectangle. So 56.52 times 5 is 282.6, and now we're going to add them up. And I have said in class, add them up, add them up, add them up, I'm on fire! Kind of like light 'em up, that song. All right, so if we add all of them together, all three sides, we get 282.6. I already have my calculator, so I'm not going to have to type that again. Plus 254.34 plus 254.34 gives us 791.28. And normally for a cylinder question, they tell you to round to the nearest tenth. So if we're rounding to the nearest tenth, round to the nearest tenth. I'm looking at this one to change, so I have to look at the next one over. 5 or more, add one more, and 8 is bigger than 5, so we're going to add one more to that too. So 791.3, and it is centimeters squared. So square centimeters. 791.3 square centimeters is your final answer. All right, let's move on to the next question, which is a composite figure of a cylinder and a rectangular prism, sorry. So what I like to do is I like to break up my workspace into two different spaces so that I can separate the two first. So we have a cylinder up here, and I like to label which one I'm doing so that I don't get confused. And down here we have the rectangular prism, just abbreviating it for RP. So I talk about this in my class, and it was kind of a difficult concept, but when you have these figures separate from each other, you can do the surface area of all the sides. But when you glue them together, the surface area, to find the surface area, it's the surface. It's what you can touch on the surface. So if you glue these two figures together at this point, you can't touch those circles in the middle anymore. So there's a circle from the cylinder that's not there. And then if you were to look at the top of this box where that cylinder meets, the circle that is on the top of that box is now gone too. So now you're missing 2 circles total that you're not including anymore when you had them separate. So rewind that and play that again if you didn't understand it the first time. But just imagine gluing 2 of those figures together. You're losing the bottom of the cylinder, which is a circle, and you're losing the top of that square in that same circle. So that's 2 circles that you're not going to include. So the only time that you're actually going to find the circles for surface area is when you do the cylinder. So I shown in my class the bottom for a cylinder, the top, and the side like we just did in the previous question. And the bottom is a circle, the top is a circle, and the rectangle is your side. So instead of doing the area of this circle for the bottom, you're not going to include it because now that's gone because you glued it onto the rectangular prism, so it's not on the surface anymore, it's on the inside. And the top is our other circle. So instead of having to go and figure out what the other area of the circle is, just don't include it to begin with, because you know you're now losing the bottom of that cylinder and the top of that cylinder space on the rectangular prism. So now we're only having to do pi d and the height, which is 8 for the cylinder, and then you can do your rectangular prism like normal. And when you add them both together, you'll get your answer. So pi d is 3.14 times the diameter. If 4 is halfway across, to go all the way would be another 4, and 4 plus 4 is 8. And pi d times 8, or 3.14 times 8, is 3.14 times 8 is 25.12. So we can change this length now, or the base of this rectangular prism, to 25.12 and multiply these two together to find the area. So 25.12 times 8 is 200.96. So that's the rectangle. Remember, we're not including these two because now it's a composite figure. Composite just means you're putting 2 figures together. So rectangular prism, we have a bottom, we have a top, we have a left, we have a right, we have a back, And we have a front. All right, our bottom is a rectangle. Our top is a rectangle. Our left is a rectangle. I wonder why they call it a rectangular prism. I don't know. Our right is a rectangle. The back is a rectangle. And the front is a rectangle. Okay, so the bottom is 14 by 8. The top is the same, 14 by 8. The left over here is 8 by, what's the height? 12. The right-hand side is 8 by 12. The back is 14 by 12. And the front is also 12 by 14. Now we're just going to go straight across and find the area of all of those rectangles. Rectangles. I can speak. I am from America. Okay, here we go. I can speak English, I mean. All right, so 14 times 8. It's only 8:40 at night. It's okay. 112. So this is also 112. And 12 times 8 is 96. Plus another 12 times 8, 96. And then 12 times 14 is 168. Plus 168. And now you're going to add them up. So add them up, add them up, add them up. I'm a fire! 112, 112. I get 752. I'm going to double check that because I was singing along with that. So 112 plus 112 plus 96 plus 96 plus 168 plus 168, 752. All right, and it is feet squared. And that is your answer for this composite figure. All right, now we're going to go into finding the missing dimension, which is a little bit more difficult. All right, so you have a rectangular prism, and you're given what the surface area of this is. So if we say the surface area of this figure is 82 square feet, you're trying to find the missing dimension. So you're going to do the same thing with bottom, top, left, right, back, front, and you're going to fill in what you know. So you have a rectangle on the bottom, rectangle on the top. Finish these rectangles, Mrs. Glenn. A rectangle on the left, rectangle on the right, rectangle in the back, and a rectangle in the front. All right, so now you're just going to fill in the dimensions. You have the bottom is 7.5 by 5. The top is the same. The left-hand side, if you were to continue this line back here, you'd have the left-hand side is 5 by h. So we don't know what h is. We just put that in there. The right-hand side is the same, h by 5. The back is 7.5 by h. And the front is the same, 7.5 by h. All right, so we're going to multiply what we can. So you have 7.5 times 5. $37.5. So that is, let me change the color. 37.5 plus, same thing, 37.5. Now with the area of a rectangle, it's just base times height. So 5 times h is 5h plus 5 times h, which is 5h, plus 7.5 times h, which is 7.5h, plus 7.5 times h, which is 7.5h. So now you're going to add like terms. And I want you to box the ones that are h's, that have an h with it. Actually, let me get rid of that box. I'm going to box the sign in the front too so that you know if it's positive or negative. And then box this one. And box this one. And then box this one. Then we're going to put circles around the ones that don't have any H attached to them. Notice how I included the sign for this one so that we know if it's positive or negative. So now we're going to combine to like shapes. So we have our circles we're going to combine together, which 37.5 plus 37.5 is, anyone? Bueller? Right, 75. And then you have 5 plus 5H, that's 10H, plus another 7.5, that's 17.5H, plus another 7.5, that's 25H. So 15 plus the 10 is 25, and their H is all on there, so keep your H there. And we know it's going to equal, in our problem they gave us, 82. So now you're going to try to solve for H. So let me give us some more room here. We have 75 plus 25H. So we want to leave H here. So if we circle H and leave it alone, I like to draw what I call a wall, and that separates my left hand from my right hand side. So I'm going to subtract 75 because that's the inverse operation. So if we go over here, inverse operation is the opposite. So it's the opposite of what you do. So if it's adding, the opposite is subtracting. If it's multiplying, the opposite is dividing. All right, so right now, these are adding, so you're going to subtract. And if you subtract on one side, you got to subtract on the other, or 82 is going to get jealous. All right, so 75 minus 75, and then you're left with 25H. So I'm going to copy this back down under here, because I like to work row or line by line so that I can keep all of my things in order. Because otherwise, if you start working over here and then work over here, you're not sure which terms you actually have used yet. So I know I've used the 75 because 75 minus 75 is 0. And I don't have to rewrite 0 plus this because 0 plus anything is the other number. So I haven't used the 25H, so I brought it down. 82 minus 75 is 7, so I can bring that down. And you're going to get rid of whatever is attached to H. So right now, whenever a variable is next to a number, that means it's multiplying, just like how we got it. 5 times H is 5H. They're next to each other. So 25 is multiplying H right now, so you're going to divide by 25 to get rid of it. So if you divide by 25 on one side, you got to divide it on the other. These cancel out, and you're left with H equals 7 divided by 25 is 0.28. So this H up above is equal to 0.28 feet. Now, I did make up these numbers here. So obviously 0.28 feet, looking at this picture, this should be around like 6, I would say. So obviously it's not proportional to the answer, but because we did all the math and we checked it all, or we could go back and check it all, it would come back to 0.28. So don't always judge the picture and just guess 6, because obviously it wasn't 6, it was 0.28 when we did the math. So the answer for this one, because you're looking for H, is H equals 0.28 feet. And no square, because it's just asking you for the dimension. When you do surface area, when you're finding all of the surface of the entire figure, then that would be square. But this is just finding the dimension. Hence the reason why this doesn't have a square on it and this one doesn't have a square on it. So to find the surface area of all of them, that would be the surface area, or that would be the square, which is 82 square feet. All right, last one, finding the slant height of this pyramid. All right, so there's one way you can do it. You can use the formula, which is on your reference sheet, and I show you how to do that in the other video. But I'm going to show you the way that we've been doing it with bottom, left, right, front, back. So let's do the bottom. And there's no top, so we're going to go to left. then right, and we have a front and a back. So the bottom is a rectangle. The left-hand side is a triangle. And with a pyramid, we know that all of them are triangles because they come to a point. At least somebody's making a point. Okay, so we have 7.2 by 4.3. And the height of the triangles you're not sure of, so that's L, cursive L. That's how you represent slant height. And the base is 4.3, and that is for all of them. Oops, hold on. There you go. 4.3, 4.3, and the height is L. All right, now we're going to do what we know. So we have 4.3 times 7.2, which is 30.96, plus 4.3 times L, which is 4.3L, divided by 2, plus 4.3L divided by 2, because that's the formula for a triangle, base times height divided by 2, plus 4.3L divided by 2, plus 4.3L divided by 2. All right, so the first thing that I would do is I would actually divide 4.3 by 2 and simplify it. So 4.3 divided by 2 is 2.15. So now you have 2.15L plus 2.15L plus 2.15L plus 2.15L. And then bring down our 30.96. So like we did before, we have box around these that have the variable, and we're going to combine all the boxes together. It's kind of like we're the garbage man or recycle man. And we're going to combine all the circles together. That one's going to be very difficult to do. Just kidding. If you knew me as a teacher, you'd be laughing right now because you know how silly I am sometimes. All right, so 2.15 times 4, rather than putting it in your calculator 4 times. Let's be a little bit more efficient. 2.15 times 4 is 8.6. So 8.6L plus 30.96. And I just realized I never gave you what the surface area of this pyramid is. So let's make the surface area of this pyramid, let's make it 374.96. So the surface area of this pyramid is 374.96. So we need to make this all equal to 374.96. All right, so the first thing we're going to do is the inverse operation to get L by itself. So you want to get rid of anything that's not attached to L. So that's 30.96. So you're going to subtract 30.96 from both sides. Draw my wall. And I like to line it up so that I know what I'm doing, the correct math. So these cancel out. You're left with 8.6L. Don't forget your variable, equals 374 minus 30.96 is 344. And then to get L by itself, right now it's multiplying, and the opposite of multiplying is division. So divide on both sides, 8.6, and then you find that L equals 40. So the height of the triangles up here is 40 millimeters. And that is how you find a missing dimension. So you plug in what you know, and then inverse operation until you get the height, or the slant height for this problem, but for the previous problem it was the height of the rectangle. So rectangular prism. So whatever you are solving for, use a variable and then reduce it down to solving for the variable. So we solved for L on this one and found that it was 40 millimeters. All right, that is the end of my video, and I hope you understand surface area a little bit better. I will see you in my next video, and make sure you visit my website. It is themathtuber.com. See you later.